Question 5 is a functions question, and it's a kind of log function question. Now, it's one of those ones where the marking scheme, when you look at the marking scheme, it doesn't look like there's too much to it. But when you're looking at the question inside in the exam, you can be asking yourself, what's going on here? So it's a bit like, we put this one in there, a bit like last year's Leaving Cert. You know, to cause a good bit of trouble in the exam. But then when you look at it after, it's not quite maybe as bad as you think. So it says the graphs of the function f of x equals ln of 5x and g of x, which is ln of x, are shown below. There is a point labeled A, which is 2f of 2, and B, which is 2g of 2. So meaning like you have your x coordinate and your y coordinate. So you have your x and your y. So, so this point up here is going to be 2 times ln of 10. When you sub in the 2, it's going to be 2 times ln of 2. So, that language can throw people off, but they're actually, there isn't anything major in there. Then it says, what's the exact distance between the points A and B? So like, how far is it from A to B? And it's a vertical distance. We can see that. So, well, what you do, you just kind of start off and you say, okay, well, again, as I said, if I put in 2 into the function g, well, it's just going to be, so g of 2 is just going to be ln of 2. F of 2 is just going to be ln of 10. So the distance between the functions is the ln of 5x minus the ln of x, because it's just going to be the difference of the y coordinates at any particular point. So when x equals 2, you're going to get ln of 10 minus ln of 2. As we remember back at question number 2, we said, like, again, if you have the log of a to the base b minus the log of c to the base b, that can be written as the log of a over c to the base b. So it's the division law. So in this case, we're going to use that because remember, of course, ln is log to the base e. So ln of 10 divided by 2 is ln of 5. And because it says the exact answer, we leave it at that, ln of 5, for 5 marks. Okay, so ln of 5, that is your distance there between those 2 points. So ln of 5. Okay, now find the value of x such that g dash x is equal to 2. And again, that kind of phrasing of a question might take a little bit of getting used to, but then you say, okay, well, if I don't know what to do, I do what I know. G dash of x, well, here's g of x. So we're just going to differentiate it. We're going to get 1 over x. And it says g dash of x is equal to 2. So we say 1 over x is equal to 2. So therefore x is equal to a half. Now I bet you, all right, I'm looking down the camera at you. I bet you lots of you didn't get that right inside the exam. Am I right? But you're looking at it now saying, oh, how did I not get that right? And the reason you didn't get it right is because you read the question, find the value of x such that g dash x equals 2, and you say, well, I've got to know what to do about that. But if you just say, if I don't know what to do, I'll do what I know, and start off and just say, well, that's differentiation. So I'll differentiate the function. The first line brings you to the second line. The second line brings you to the third line. In this case, the third line is the answer. And the thing about it is, right, if there was no part A, you probably actually have done better at part B. But because people might have got thrown by that first part, they find they get thrown by the second part. The second part of B part 2 says h of x, which is another function, is ln of kx, where k is greater than 0. Find x such that h dash x is equal to 2. So again, right, I bet you a lot of people didn't get this right, or left it blank even. But if you just start off and say, okay, I'm going to differentiate the ln of kx, well, that's 1 over kx times the derivative of kx, because it has to be chain rule. The derivative of kx is k. The k's cancel, and you get 1 over x. So the derivative of h of x is 1 over x. and it says, okay, find x such that h dash x equals 2. So 1 over x is equal to 2, x is equal to half. So it turns out that that's the same answer as the previous part. And those of you who might like to think about it a little bit more would see that that will always happen, that the coefficient here in this type of function would always cancel. So I'll let you ponder that one, but another 5 marks. So comment on the relationship between the graph of g of x, which is ln of x, and h of x, which is the ln of kx. So again, if we think about this, and we remember what we said earlier, that the log of a to the base b plus the log of c to the base b can be written as log a c to the base b. It's called the multiplication law. So if you have in the power two things multiplied together, in my case over here, a times c, if we have log a times c to the base b, we can write it as the log of the first one to the base b plus the log of the second one to the base b. Now in this case, this is the log k times x to the base e. So we can write that as log ln of x plus log k plus log ln of k. So again, remembering, I'll just add this in just for some people. Some teachers might just always write it now as log to the base e rather than ln. So log k times x to the base e. I'm putting the x first, so it's log x to the base e plus log k to the base e. So then what we're saying is, right, what is the connection between the two? Well, if you're starting off at g of x and you're going to h of x, what you're saying is that it is a translation of the original function, which was ln of x, by ln of k. So you're just shifting it upwards by whatever ln of k is. So depending on what the value of k is, that's what you're doing. Because the only difference between h of x and g of x is this part. So it's a translation by the ln of k. So people might have struggled a bit with that language, but hopefully you kind of have the meaning of it. Then find the equation of the tangent at point B. So we know the tangent is going to be a straight line. We know what the point B is. It's 2g of 2, and we said that's 2 times ln of 2. We need to find the slope, but the slope is straightforward enough, isn't it? Because we know that when we differentiate it, g dash x was equal to 1 over x. So we said g dash 2 was equal to 1 over 2. So my slope is a half at that point. We fill it in. Y minus ln of 2 is equal to half times x minus 2. And in fairness, that is the equation, but we might as well tidy it up a little bit. And when we do that, we're going to, when we multiply in this line here, we're multiplying everything here by 2 to get rid of that half. I'm going to multiply through the bracket now. So 2 times y would give me 2y. 2 times minus ln of 2 will give me minus 2 times ln of 2. And I'll just write that as log 2 to the base e as a reminder for a second equals x minus 2. And again, I can use my power to the front law here in reverse and say basically the log, if I have minus 2 times log 2 to the base e, I can bring that first 2 up as a power. I get 2 to the power 2, which will give me 4. And of course, I remember that it would be, I'm just looking at that there just to see is that absolutely correct. I actually think there might be a little tiny typo there. So let me just have a look at this. I'm going to, if I go back here one line and say if that wasn't there, what would I write? So I'm going to say, okay, I'm going to bring everything over here to the right-hand side. So I'm going to get 0 is equal to x minus 2. So that's what I have on the right-hand side. I'm going to have a minus 2y, and I'm going to have a plus 2 times the log of 2 to the base e. So let me keep going here. That implies I'm going to say x minus 2y. I'm going to minus 2, and then I'm going to have a plus log 4 to the base e. And so my final answer, so that'll be equal to naught. My final answer will be x minus 2y minus 2, and I can say plus ln of 4 equals 0. And that will be my final answer. Okay, so that question, of course, you could see how it could be confusing for people, that little part, the language involved in it. The maths, like again, the marking scheme would look short, but there was a lot of work to be done to kind of understand each part and make your way all the way through it. Okay, so that's the end of question 5, nearly at the end of the short question. So let's have a look at question 6.